Use separation of variables to solve the differential equation for the sugar mixing problem and check your solution. All right, this is part of the lesson 1.2 demo. Okay, ds dt is 20 minus 0.03s. That's the differential equation we got for the sugar mixing problem. I'm going to solve using separation of variables. So separation of variables says get all your s's on one side and all your t's on the other. That includes the ds and the dt. You treat that like a fraction. So to simplify this, I'm going to rewrite it as 1 over 20 minus 0.03s ds equals dt. Just a little algebra there. Now all my s's are on the left and all my t's are on the right, and I integrate both sides. All right, so the left side, I'll have to do a u substitution. I'm not going to write out all the work just to save space, but you would let u be 20 minus 0.03s. And then calculate ds and substitute in. So this ends up being negative 100 thirds times the ln of 20 minus 0.03s. And technically there's a plus c, but I'm going to combine both of my plus c's on the right-hand side. So when I integrate dt, I get t plus c. Now I just need to solve for s. So I'm going to move the negative 100 thirds to the right-hand side. So multiply both sides by negative 3 over 100. And I have the ln of 20 minus 0.03s equals negative 0.03t plus, technically, I'm multiplying my arbitrary constant by negative 0.03 also, but that's just a new arbitrary constant. So I'm just going to keep calling it c. Okay, so now I just need to get the s by itself. To undo the logarithm, I'm going to raise e to both sides. So e to the ln of some stuff is the stuff. And this is going to be, I'm going to rewrite this as e to the negative 0.03t times e to the c. Because when you're multiplying like bases, you can add the exponents. So I have added exponents, so I'm rewriting it as multiplying like bases. Now, e to an arbitrary constant is just a new arbitrary constant. So I'm going to rewrite this as 20 minus 0.03s equals c e to the negative 0.03t. And now I'm just going to subtract 20 and divide by negative 0.03 and get my formula for s. So negative 0.03s is c e to the negative 0.03t minus 20, and then divide by negative 0.03. So I get s equals arbitrary constant c divided by negative 0.03 is just a new arbitrary constant, so I'm just going to call it c again. And 20 divided by 0.03 is 66 2/3. Oh, sorry, 666 2/3.